You asked for a fix. You got 12 tidy lines back. Every test went green, and you shipped it before lunch. 2 weeks later, production found the one input nobody thought about, including the model. Claude Code is the first thing I open every morning. It is genuinely brilliant. That is not the argument here. The argument is that the bugs changed. We spent years building instincts for human mistakes. The junior who forgot the null check. The senior who got clever with inheritance at 11 p.m. You learn the shape of those. You can smell them in a diff before you have finished reading it. AI-written code does not fail in those shapes. It fails in new ones. The logic is confident. The naming is perfect. The structure is exactly what you would have written yourself. And the defect is sitting 3 layers down where nothing about the presentation warns you. So today, 6 new categories of bug you only get from AI-written code. Not tech debt this time. Actual bugs, the kind that paid you. Let's start with the one that gets absolutely everybody. The first one is the confidently wrong edge case, and it has got me more than once. Here is the pattern. You describe what you want. The model writes the happy path beautifully. It handles the case you described, and it handles it properly. Then you look at the boundaries, and there is nothing there. No crash, no to-do. Just a quiet assumption that the list is never empty, that the date is never the last day of the month, that the user always has a billing address on file. Human bugs at the edges usually look like bugs, a missing branch, an ugly condition, a comment saying, "Handle this later." The model does not leave a gap. It fills the gap with something plausible. Ask it to parse a duration, and it will pick a default for the ambiguous case silently. And that default will be reasonable in general and wrong for you specifically. I watched a rate limiter do exactly this. Genuinely lovely code. The reset window was computed off local time. Fine in staging. Fine in London. Spectacularly broken for every user the clocks moved under. The edge case was not missed. It was answered, confidently, and nobody thought to ask what the answer was. The second one costs you the thing you rely on most, which is knowing when something is broken. The error that gets swallowed on its way out. Ask for robust code, and you will get robust code. Try blocks everywhere. Nothing throws, nothing crashes. And that is the problem, because one very common way to achieve robust is to catch everything and return a sensible-looking default. An empty array instead of a failed fetch. Null instead of a timeout. A warn level log line nobody has an alert on. The function returns, the caller carries on, and your dashboard stay a beautiful flat green while a third of your writes go nowhere at all. I have debugged this in a payment sync. Records stopped arriving. No errors, no alerts, no spike on any graph. Someone had accepted a helpful-looking refactor that wrapped the whole loop in a catch and continued to the next item. It ran quietly for 9 days before a finance person noticed. Humans swallow errors out of laziness. Usually in one place, usually with a guilty comment above it. The model swallows them out of politeness, consistently, everywhere. And the code looks more careful for it. Absence of errors is not evidence of correctness. Sometimes it is just good manners. Number 3, and this one walks straight through code review, because at a glance it looks correct. The type that is almost right, not wrong, almost right. A number where the rest of the system uses a string. Seconds where everything else is milliseconds. Pounds where the ledger is in pence. An ISO string handed to something expecting a real date object. Snake case keys from your API mapped into camel case models with 2 fields quietly dropped on the floor. This happens because the model is inferring shapes from context, and context is always a partial view of your system. It saw the function signature. It did not see the migration from 2 years ago, where amount became an integer of minor units. So it writes something perfectly coherent with what it could see, and coherent with the wrong half of your code base. Static types catch some of it. Then someone adds an any to get the build passing, and now the compiler is agreeing with the bug. The tell is that these never blow up at the boundary where they were introduced. They blow up 4 services later, in a report, in a currency conversion. in an invoice that is off by a factor of 100. And by then, nobody remembers the diff. Here is the fourth one, and it is the hardest of the lot to catch because it refuses to reproduce. The race condition nobody ever reasoned about. Concurrency is not a syntax problem. It is a reasoning problem. It needs someone to hold two timelines in their head at once and ask what happens if these arrive out of order. Generated code is excellent at the syntax of concurrency. Promises resolved in parallel, async, and await in all the right places. Worker pools, all of it correct. What it cannot know is that your endpoint gets called twice because the mobile client retrieves on a flaky connection. So you end up with red modify right and no lock. Check then insert with no unique constraint underneath it. An idempotency key generated inside the handler instead of sent by the client, which means it is not an idempotency key at all. It is decoration. It passes review because every single line is defensible on its own. It passes tests because tests run one request at a time, politely, in order. Then a traffic spike arrives. Two pods pick up the same webhook, and you refund somebody twice. The model never reasoned about the race. It reproduced the shape of code written by people who had. This next one is specific to working with agents, and if you drive Claude code the way I do, you have absolutely hit it. The fix that quietly changed 4 other things. You pointed at a bug. It finds the bug. It also notices a helper 2 directories over that looks similar, tidies that up, flips a default from false to true because true reads more sensible, and updates a shared constant while it is in the neighborhood. Every individual edit is defensible. The diff is 140 lines, and 9 of them are the thing you actually asked for. This is not the tool misbehaving. It is doing what a thorough engineer would do. The difference is that a thorough engineer knows which of those files 3 other teams depend on, and the agent does not, because that knowledge lives in a Slack thread from March that nobody wrote down. So the reported bug gets closed, and something completely unrelated starts failing next Tuesday, and nobody connects the two. The discipline that saves you here is boring. Small, scoped requests. Read the whole diff, not the summary. And when the agent tells you what it changed, believe the diff, not the sentence. And finally, the one that ties every other point together. The bug that only exists in production. Generated code is written against an imagined runtime. Clean input. One process. Small data. A network that always answers quickly with the shape it promised. That is the world the model has seen described most often. Your production is not that world, so the code is genuinely correct on your machine. Then it meets 6 pods behind a load balancer, and the tidy in-memory cache is now 6 inconsistent caches disagreeing with each other. It meets a table with 40 million rows, and that innocent query inside a loop becomes an n+1 that drains the connection pool at 9 in the morning. It meets a third-party API that returns a 200 with an error inside the body, because that is a thing people genuinely do. None of this looks like broken code. It looks like working code that has not met reality yet, which is exactly why review does not catch it and staging does not catch it. The only defense I have found that works is to stop reading generated code for correctness and start reading it for assumptions. Ask what this code believes about the world, then go and check whether production agrees. So here is the honest takeaway. AI did not make your code worse. It moved the failures somewhere your instincts do not look. The old bugs announce themselves. Bad structure, ugly names, obvious gaps. You could review your way out of trouble. These new ones hide inside code that presents perfectly, which means the polish is now working directly against you. Claude code is still what I reach for every day. I am not giving it back, and neither should you. But I read what it produces differently now. Not is this correct? What does this assume, and who actually verified that assumption? That is the whole shift. The model is confident by design. Your job is to be the part of the system that is not. If you have shipped at least 2 of these, and you have, you know what to do. hit subscribe. And next time the diff looks too clean, read it twice before you approve it.